Start. Good evening, everyone. Today we will present our final project titled Spotify's Musical Landscape, a visual journey through the data. This was a group project and it was, of course, a great learning experience for me and my project partner Anirudh. So now let's dive in. First, let's talk about the data set. We have implemented this work on the original Spotify data, which was directly fetched from Spotify through API call. Along with the data, we combined two other datasets, Spotify YouTube data and artist information data from Kaggle. Finally, the dataset was cleaned and filtered to keep the total 12 numerical attributes and 6 categorical attributes. With all this data, now let's talk about different visualization tools and plots that we have used. First, we have a choropleth map, which basically indicates the heat map of country-specific distribution of tracks. Here, darker color indicates more tracks from those countries, and lighter color indicates less tracks. Then we have a bar chart of top N artists in a given situation, along with their track numbers. Here, N can be less than or equal to 30, given a particular situation. We also have a donut chart, which depicts the distribution of different genre of tracks. We demonstrate the correlation among different tracks using a parallel coordinate plot. And finally, we have a tree map that shows the distribution of total number of tracks in all the keys. So these are the total 5 plots that we have, and all of them are interactive. So now let's talk about the interaction of the plots. We have several filtering options based on thresholding of certain attribute values, country-specific songs, artist-specific tracks, and filtering based on genre and key information of track. So here is an example of change in all the plots. If we set the threshold of valence greater than 0.75, clearly all the plots before and after are changed a lot because only 20% of the data or tracks are filtered by this thresholding. We also have a few insights from the data. For example, some specific countries like Hungary and Congo have noticeably higher percentage of instrumentalness in their songs because these songs have historical and cultural significance, and in this context, instrumental music often plays a more prominent role than vocal music in these countries. Similarly, genre like pop and dance pop have noticeably higher number of streams because they are designed to be catchy, appealing to a wide audience, and because of their upbeat nature. Also, album songs are more popular than single songs. So these are just a few interactions and insights example. Details of these plots and their interactions will be shown in the live dashboard by Anirudh.
Hi, everyone. Let's go to our live dashboard. So before we start diving into exactly how these plots functions and the interactions, let's understand the motivation. So it's very easy to visualize how popular songs are, like plotting a map or showing statistics regarding stream counts and stuff like that. But we also wanted to visualize in parallel to that why these songs might be popular and in what manner they might be popular, what factors might contribute more or less to the popularity of these songs. To that end, we used 5 plots here. These 5 plots are a choropleth, which is color graded in terms of the number of tracks originating out of each country. The darker colors indicate that a large number of songs originated out of that country, while the lighter colors indicate fewer. We have an artist-specific bar chart, which depicts the number of tracks released by each artist. We filter it out to show the top 30 artists or fewer at any given moment. And then we have a donut chart, which shows the top 10 genre in the current state of the data set that is being visualized. And then we also have a parallel coordinates plot, which shows the correlation between various numerical attributes that are present in the data set. This is the most important part in terms of how we can visualize what makes songs popular the way they are. We also have a tree map that shows the relative distribution of songs in terms of what key they are composed in. So the 12 natural keys. Another important thing is that we have the bottom left box shows the total number of tracks currently being visualized. Right now, we're seeing the full data set. So there are 32,571 songs, 100% of the data set. Regarding the interaction in terms of the parallel coordinates plot, we have the top left box, which we will explore in detail later. Another thing that I should mention here is that the coloring in the parallel coordinates plot is done through k-means clustering. We found that the ideal number of clusters through the elbow method is 3, and then we clustered them and colored accordingly. So we have 3 colors here. Now let's take a look at the interactions that we have on this dashboard. First of all, we have information on hover. So all of these plots, when we hover on any of these segments, show us a few information or statistics regarding that segment. For instance, in the Chloropeth, if we hover on any of the countries, shows the number of tracks, artists, and the genres that are contributed to the dataset from this country. Similarly, from the artist bar chart, if we hover on any of the bars, it shows the artist's name and the number of tracks that they composed. And then we have the genre chart, the same statistics, but in terms of the genre. And exactly the same for the tree map as well. The key that the song was composed in and the number of tracks that are composed in that key. All of these maps are linked two-way. So clicking on any of them updates all of the other maps to represent the data. So let's explore that. First of all, in the Chloropeth, if we click on any of these countries, the dashboard will update to demonstrate or visualize the data specific to that country only. So let's click on Australia first. So when we click on Australia, we can see that clearly the PCP has changed, although it's not very visible from the genre that it has changed, but we can see how it has changed. So if we reset the map, you can see that the original data was predominantly rock and pop. But when we click on Australia, we can see that the genre distribution is dominated by R&B and Australian dance, Australian rock, and of that sort. So there's clearly a change here. And also the PCP is very visibly changed in terms of the cluster colors. Also, the artist bar chart has updated to show us that the top 2 artists are Chris Brown and Logic, and the original chart shows that the top 2 artists were Chris Brown and Phoenix. So Australia brings a significant change in this as well. Now let's look at the second chart. If we click on any one of these bars, it will update to visualize data specific to this artist. So let's click on Logic here. We can see that, as expected, an artist will not release songs from a lot of different destinations or a lot of different countries. So Logic is restricted to specifically a few places in Europe, Australia, and then US. And Logic is a rapper, so it's understandable that the genre distribution of his tracks is predominantly hip hop, which makes sense. Another thing that makes a lot of sense is that hip hop is very speech focused and rap is very speech focused. So the attributes here, we can see that Logic's songs are very low in terms of instrumentalness. So they're very speech focused, but they're also very loud and they're not very acoustic. So that's an interesting insight that we can derive from here. So now let's take a look at the third map, the donut chart. If we click on pop, this brings about a relatively better distribution since the genre is not restricted to a specific country, usually not restricted to a specific country. So it's more well-balanced and distributed in the Chloropeth. Also, we can see that the top 30 artists chart has also changed. So people contributing to the pop genre include Mabel, Sam Smith, and others. And we can also see that there are visible, strong positive or negative correlations between the attributes. For instance, songs that are very loud in the pop genre are not very instrumentalness. That means they're loud because of the speechiness of the song and the verbality of it. Moving on from this, if we filter out in terms of the tree map, let's pick a key. Let's click G. So now we are visualizing songs that are only composed in the key G. So we can see that it's very well distributed in the Chloropeth. Also, the top 30 artists is also well balanced in terms of this. So a lot of artists compose songs in the G key. Another interesting thing is that while the artist-specific bar chart when clicked or the genre donut chart when clicked showed very clear correlations in terms of attribute values in these numerical attributes in the PCP, the key, however, does not show that. So it's not directly strongly correlated with any of these attributes. So it's more well-balanced. So we see a wide distribution of attribute values in the PCP when we click on a specific key. Now let's reset this chart and look at the top left box here. So we wanted to be able to visualize by thresholding in terms of one of these attributes and seeing tracks that have a high value for any one of these specific attributes. So here, as you can see from the drop down, we can pick any one of these 8 attributes. We have picked that. Let's stick with danceability. It's fine. And so let's right now, this is a stock plot. So if we click update here, it will threshold the data for this attribute and this value. So let's stick with this. It's fine. Or we can just select a higher value. Let's select a high value for danceability, say 80%, 81%, and update the charts. So these are songs that are very danceable. As you can see that the genre distribution has updated to show that dance pop, alt hip hop, and reggaeton are the most danceable genres. Also, you can see that the songs that have high danceability also go hand in hand with very loud songs. They're also very loud songs. Also, very few danceable songs are low energy. Most of them are mid to high energy. Also, danceable songs are not very acoustic in nature. They're usually very they usually use a lot of electrical instruments. So that's another interesting insight. Now I want to demonstrate a few other interesting insights that we might come up with. So let's click Norway here. The reason I did this is because we want to show you a specific genre. So the fact that the genre strongly influences attribute-specific correlation, you can see when you click classical. So the classical genre features songs that are from the Western classical genre, and they are, as we all know, they are mostly played through acoustic instruments. They use almost little to no electrical instruments. So their acousticness value is understandably very high. And also, they're not speech focused at all. Most of them are just instrumental pieces. So they have very high values in instrumentalness. So that's another interesting insight that we can understand from this. And they're not very danceable, classical Western pieces. So that's one more interesting insight. So resetting this, and another interesting thing is that the PCP shows that this is relatively well balanced in terms of the cluster colors, right? So let's do something. We filter out to the C# key. As you can clearly see, the orange cluster is predominantly songs that are composed in the C# key. Let's iterate through the other keys, C, G, A, F, E. As you can see, the other keys do not have a lot of songs in the orange distribution or orange cluster. So clearly the key C# has something to do with these songs being clustered in the same group in the orange cluster. So that's also interesting. So obviously the key has some role in terms of how songs are similarly grouped. So yeah, another thing that we might view here is that during the poster that was presented, my teammate mentioned that certain songs, geographically speaking, have very high attribute values and correlations. So the Democratic Republic of Congo, most of the songs from this genre, from this country, come from the Afrobeats genre in our data set. So these are very instrumental in nature and very highly acoustic in nature. So you can see what my teammate was talking about during the poster presentation. So yeah, this was our dashboard. It sort of makes a good attempt to visualize the Spotify's musical landscape, as we call it. We hope you enjoyed the presentation. Feel free to reach out to us if you have any questions about this. Thank you.